Unit 4, Quadrilaterals. Section 1, Defining Quadrilaterals. Let's start with a basic definition, and that is a regular polygon. Now, polygon means a shape that is closed. It's not open. All the sides come together per se. It's not concave and so on. But regular means something even more, and that is that no matter what the polygon, you have, in case it's a triangle, if it's called a regular polygon, which is the key here, you have all angles are equal, which means equal angular. All sides are equal, which makes it equilateral. And that can be any shape. So if I give you a pentagon and say it's regular, and only when I say it's regular, can you claim then that all the sides are the same length and all the angles are the same length? So with that knowledge, we can do quite a few different types of questions. Let's take our focus now and discuss some properties with interior angles of a polygon. Now, just to make sure we're on the same page, if I draw a triangle, all these angles are interior. But if I extend one side, this would be considered an exterior angle of that shape. So I state that because we're going to focus first on interior angles. Now I drew a triangle there, and we've been dealing with triangles quite a bit, and we've used this property, and that is that all the angles in a triangle add up to 180. When we go beyond three-sided shapes, so we have a different kind of sum. So like I said with a triangle, we know that there are three sides. So n would be 3 in this case. We'll call that n represents number of sides. A quadrilateral, we'd say n is 4 because there's 4 sides. And we know already from past units that the triangle, all the angles in a triangle add up to 180. In other words, well, hang on a second. If we go to a quadrilateral, if I split it into 2 different triangles, this would add up to 360 because there's 2 triangles inside it. And there's a formula that goes with these, and that is basically you take 180 times the number of sides there are minus 2. That formula then can be used to help you find out the sum of all the interior angles of a shape that has many more sides than just a triangle or a quadrilateral, say an octagon and whatnot. So here's your formula for something like that. So let's try a couple of those. We have a question that says, what's the sum of the interior angles of a hexagon? Now a hexagon has 6 sides. So we're going to take the number of triangles, each one representing 180 degrees, and we can find out how many triangles there are by basically just taking and doing this formula. So we'll have 180 times, and a hexagon has 6 sides, take away 2. And that would give us a total of 720 degrees. Now again, a hexagon, 6 sides, 1, 2, 3, 4, 5, 6. If I start at this vertex, I can draw 3 lines that cuts that shape into 4 different triangles. And that's where this comes into play. Each triangle is 180 degrees. Next question. What is the number of sides in a polygon? So number of sides in a polygon if its interior angles have this sum. Now here we have the answer. So we know that if we took 180, took the number of sides minus 2, which we don't know, we would get 2,520 degrees. So this is a question of working backwards. So I would recommend the first thing you do is divide by 180. Because when you divide by that angle sum by 180, you're going to find out how many triangles are in the shape. And we would get 14. Now remember, you're not done yet. 14 is the number of triangles in the shape, but we would have to add 2 to find out then how many sides there are. Because remember, three-sided shape is a triangle, which is one triangle. So 16 sides for this question in order to have that sum. What's the measure of one angle, one interior angle in a pentagon? Well, if it's regular, they're all the same. So we have to first find out what is the sum of all of the angles in a pentagon. Well, there's 5 sides in a pentagon. So if I take 180 and I go n, which is 5, so this is 5, so 180, and then 5 minus 2, we get 180 times 3, which is equal to 540. Now that's the sum of all the angles in a pentagon. They're all the same, so if I divide by 5, because there's 5 angles, I get each, and that's 108 degrees each. Now we're going to turn our attention to exterior angles, and then we'll be done with this piece. Now, as I mentioned before, exterior angles, if I extend a side, that's the exterior angle. If I extend that side, that's the exterior angle. If I extend that side, that's the exterior angle, compared to the interior ones, which we just got done talking about. Now, the nice thing about exterior angles, it's like walking around a building. You would rotate 360 degrees, no matter what shape it is. Once you walk around the building, you have done a full circle. So that is a very nice piece to exterior angles. They're always going to add up to 360. So in the first question, what's the sum of the exterior angles of an octagon? Well, we don't even care what shape it is. It's going to be 360. And that's the fun part. What's the measure of one exterior angle of a regular octagon? Now this one's a little bit different. We know that they add up to 360. The question is, what is each one of them? Well, since it's regular, they're all going to be equal. So the question really is how many exterior angles are there in an octagon? Well, an octagon has 8 sides, so there's 8 interior angles, 8 sides, and 8 exterior angles. So let's divide by 8, and we would get an exterior angle of 45 degrees.